With this video, I want to introduce how we handle ions. So what do? Let's just focus on anions here. I'll talk about cations in a second. Well, just like any kind of Lewis structure, you want to count up valence electrons first. So let's do that. We do it just like we did in the previous example. For carbon, there are 4 valence electrons. There's only 1 carbon. Okay. Each hydrogen, right, so has 1 valence electron. There are 3. And then what we have, and I don't want to subtract, I want to add, and then what we have to realize is that when we have an anion, something with a negative charge, that means it's actually gained electrons in the process of it being created. So I'm going to add 1 electron to the valence electron count. And 3, 4, 8. I got 8 valence electrons. And just like I did on the previous example, I'm going to have a central atom. In this case, it's going to be carbon sitting there. And then I say it's the first atom is a central atom unless otherwise indicated. And then what I do is I lay out all the other atoms just sort of symmetrically around the central atom. That's fine. First thing I want to do is I want to go in my pool of valence electrons and just connect everything together and see how many I've used at that point. Okay. So I've used 1, 2, 3, 4, 5, 6. So minus 6. Sorry about squeezing in there. 6 used. I'm going to have 2 left. 2 electrons left. Where do they go? All right. Well, we got to focus on our octet rule. That's usually the first thing you're shooting for. Okay, well, each hydrogen already has 2 electrons around it, right? We talk about these shared electrons. So it's that covalent bond is going to be counted toward the hydrogen as well as the carbon. If I look at the carbon, well, I see a problem. 2, 4, 6. It's not 8. How do I get 8? Well, I'm going to put lone electron pairs on that carbon. Remember, the leftover electrons, and it's in the previous set of rules. Yeah, the leftover electrons, that's what they're going to be used for. Multiple bonds and lone electron pairs once you establish the initial connectivity around the central atom. And that's it. That's the structure. I've used up all of my electrons, right? 8 electrons being used. 2, 4, 6, 8. Octet rule is fine. Carbon looks a little weird than it normally does, but that's okay. Basically, if your molecule fits with the rules of Lewis structures here, we say it's a valid Lewis structure, even though it may look a little bit different. These rules work pretty well for most of these simple structures. Actually, the vast majority of molecules that you'll ever see, these work really well. You want to also account for the charge that you see on the structure. I don't have a negative charge yet. Now, in a lot of examples, you may see something like this for that molecule. Brackets around the molecule and the negative charge on the outside. That's okay for like an introductory class in chemistry, I think. It's not okay for college level chemistry. Let's look at the proper way to do it. Okay, what I actually want to do is place the charge directly on the atom that's carrying that negative charge. The formal charge, again, is the actual charge on that atom. And so I want to spread that out. I want to specify which atom is carrying that charge. Let me just go ahead and do hydrogen real quick. It's the same formula as the last video. 1 valence electron for hydrogen, 1 bond. And I didn't want to put that. Let's say I want to put that. No lone pair electrons, 0. Okay, so I'm not going to do any more hydrogens. I'm not going to do formal charge for hydrogen anymore because it's always 0 when it's just a single bond there. It's going to be the other atoms. Let's do the formal charge on that carbon so we can see what in the world is going on. Formal charge here, just like any other atom, valence electron count first. Right? I'm looking at this. Valence electron count minus the number of bonds minus the number of lone electrons. Again, not lone electron pairs. Lone electrons, the actual number of dots that you see. So I got 3 bonds, and I have 2 lone electrons. What's the math here? Well, 4 minus 3 minus 2 is minus 1. Minus 1 matches up with the minus 1 here. So now that I've determined that that carbon is carrying a minus 1 charge, then I want to apply it directly to that atom there. And there's my complete Lewis structure. Again, a recap. It fits all the rules. Rule 1, valence electron count, 8 electrons used, no more than 8, no fewer than 8. That's good. Yes, connected atom together. Octet rule's fine. 8 for the carbon, 2 for each hydrogen, and then the formal charge. Right? 0, 0, 0, minus 1 equals minus 1, and then that matches the overall charge of the molecule. Last thing I need to mention, I forgot to mention it earlier, if you have a cation, it's the same process. It's just that you would remove however many electrons based on the charge. If it's plus 1, you remove 1 electron. Plus 2, you remove 2 electrons. Remember, with a cation, you're actually subtracting. You're removing electrons from the molecule.